Dear students, in this video we are going to learn about logical equivalence, the laws of logic. So what is logically equivalent statements? So if you are having two statements S1 and S2, when you will call these two statements are logically equivalent statements. Whenever S1 is true, S2 must be true. So that is when S1 is true, if and only if S2 is true. When S1 is false, S2 must be false. So that you will get the same truth values as S1 and S2. See here, we are having the first example is negation PRQ, which must be logically equivalent to P implies Q. We have to prove. Okay. So negation PRQ must be logically equivalent to P implies Q. So in the first video itself, I have taught you what is basic connective, how you will draw the truth table for the basic with basic connectives, right? So here we are having P and Q as two statements. So what are the combinations you will write? 0, 0, 0, 1, 1, 0, 1, 1. Okay, so what is the first thing we have to identify? It is negation P, and then negation P or Q we have to find, and finally we have to find P implies Q. So this is statement number 1, this is statement number 2. So we have to prove these two statements are logically equivalent statements. So how you will prove? You will get the truth values as same for both the statements. Okay. So what is negation P? Here we are having 0, so you will get 1. 0 will become 1. 1 is 0, 0. So what is negation P R Q? So 0 or 1 is 1. 1 or 1 is 1. 0 or 0 is 0. 1 or 0 is 1. So next we have to identify what is P implies Q. See here we are having P and Q here. So 0 implies 0. If you are having the same value, truth values are same, then you will get it as true. So 1, 1 is 1. Okay. So what is 0 implies 1? It is 1. A false statement can be a true statement. A true statement cannot be a false statement. Okay. So it is 0. So 1, 1, 0, 1, 1, 1, 0, 1. So both the statements we are having, whenever S1 is true, S2 is also true. So when S1 is true, if and only if S2 is true. If you are having S2 is true, S1 is also true. If S1 is false, S2 is also false. So you will get the same truth values as S1 for S2. So these are logically equivalent statements. So when you see the another statement, see here, the second problem is P and negation Q R R and P R Q and negation R. You have to identify whether these two are logically equivalent statements. If you do this, you will not get these two statements as logically equivalent statements. You can try this. Okay. So next is laws of logic. So there are 10 laws for logic. So first law is law of double negation. What is law of double negation? It is you have to, if a statement is given, then you have to negate the statement 2 times. So for example, if we are having P, what is negation of negation P? It is logically equivalent to P. Okay, this is first one. So second one is De Morgan law. What is De Morgan's law? It is nothing but negation of P and Q logically equivalent to, if you take inside the negation, it will become negation P and will become R negation Q. You will get. So second law is negation of P R Q is logically same as negation P. R will become and here. So and negation Q. So these two are law of De Morgan. So they may ask you to draw the truth table for these laws. In that case, you know what is the law. You have to draw the truth table for this statements. Okay. So next law is commutative law. What is commutative law? So whenever you are having the word commutative, you must have two statements. It should commute with each other. That is, if you are having P or Q, which is logically equivalent to Q or P, and P and PQ is logically same as Q and P. So these two are commutative law. So next is associativity. So that is associative law. For associative law, you must have three statements. Okay. So P, R, Q, R, R. It is logically same as P, R, Q. If you change the order, that is changing of the brackets will not change anything. Okay. These two are logically equivalent statements. This is associativity. Okay. So PRQ or R is logically equivalent to PRQ or R, and P and Q and R is logically same as, that is logically equivalent to P and Q and R. This is associativity. Okay. So next is distributive law. This is an important law. Okay. So what is distributive law? You must have three statements for distributive law. If you are having P and Q, Q or R, okay, which is logically same as, which is logically equivalent to, if you take inside P and, okay, if you take it inside, it will become P and Q. What is the connective in between here? It is R. And take here also. Okay. Take here as well as here. So P and R. This is distributive law. So next you have to change the connective. Here we have taken and R, right? So here P, R, Q and R. It is logically equivalent to. So here if you take P and PR inside, it will become PRQ. What is the connective we are having? And PRR. This PRR. This is distributive law. So if they ask you to prove the distributive law, you have to write these two laws and you have to draw the truth table for these laws. So next law is identity law. What is identity law? If you operate with some statement, you will get as operate with CP, R, F naught. Here we are having R and F naught, right? Which is logically equivalent to P. See, if you can put the truth table and you can verify. If you are not remembering the law, you can easily put the truth table and you can write. See here, P, F naught we are having. What is P? It is 0, 1. What is F naught? It is contradiction, 0, 0. So what is PR F naught? It is PR F naught. 0 or 0 is 0. 1 or 0 is 1. So what you will get, it is same as P, right? And if you find P and T naught, which is logically equivalent to P. So you can take P, T naught, P and T naught. Okay. So what are the values of P? Either it may be false or it may be true. What is T naught? It is both 1. What is P and T naught? It is 0 and 1 is 0 and 1 and 1 is 1. So what we got here, it is same as P. So P and T naught is P. Okay. So this is identity law. So next law is inverse law. So what is inverse law? It is nothing but P and negation P is logically equivalent to. We have to find. See, you can easily find what is P negation P. It is 0, 1. What is negation? 1, 0. If you put P and negation P, what you will get? If you take and between 0 and 1 is 0. 1 and 0 is 0. What is P R negation P? If you take R, 0 or 1 is 1. 1 or 0 is also 1. So here we get contradiction, that is F naught. Here we get tautology, that is T naught, right? So P and negation P is F naught, and PR negation P is logically equivalent to T naught. So this is inverse law. So next we are having domination law. So one statement will dominate one another. Okay. So here, what is domination law? It is P and F naught. It is logically equivalent to F naught. Here, when you operate with and F naught, you will get F naught. Here, F naught is dominating the statement P. Okay. And P or T naught is logically equivalent to T naught. So you can use the truth table and you can verify also. See here, P, F naught, P and F naught, right? So what are the possibilities of P? It is 0 or 1. What is F naught? It is 0, 0. So and means 0 and 0 is 0. 1 and 0 is also 0. What is it equal to? It is equal to F naught. In the same way, you can check for this, the second law of domination, PR T naught, which is logically equivalent to T naught. This is domination law. So next law is absorption law. So what is absorption law? You have to take one statement two times. Okay. So here P, again we are going to take P. If you take here cup, take here cap, operate with some other statement Q. It is same as, it is logically equivalent to P. This is absorption law. Okay. So next law is P, and if you change the connective, here or, here you can take and. If you have and here, you can take or. So P and P or Q is logically equivalent to P. So this is absorption law. So final law is idempotent law. What is idempotent law? You have to take same statement two times and you have to take only one connective at a time. So if you are having P and P, what is P and P? It is nothing but P, logically equivalent to P. And P or P, it is also logically equivalent to P. These two laws are called idempotent law. So first law is law of double negation, De Morgan law. Commutative, you have to take two elements, two statements, and we have to check for the commutativity. Okay. Associative, distributive is fourth one, and we have seen identity, inverse, domination, absorption, and idempotent. So these are all important laws. So we will use these laws to simplify the compound statement. So before that, what is dual? Dual of a statement. So if a statement is given like this, P and negation Q, R and T naught. Okay. So how you will find dual of the statement? So they have given S as a statement, right? So S may be any statement. It should contain logical connectives, okay, only cap and cup. It should not contain any other logical connectives other than these two, okay, cap and cup. So whenever there is an occurrence of cap, you have to replace it by cup. Whenever there is an occurrence of cup, you have to replace it by cap. And whenever there is contradiction, you have to replace it by tautology. If there is tautology, replace it by contradiction. Okay. So in this statement, you can see P and negation Q, or R and T naught is here, right? So how you will write? See here, we are having P and negation Q. So and will become R here. So what is dual of the statement? It is denoted by SD, like this. Okay. So P and will become R. So PR negation Q. And here R will become and. Okay. R. Here we are having R as it is. And will become R. That is cap will become cup. And T naught will become F naught. If you are having F naught, you have to replace it by T naught. This is the dual statement for the given statement. Okay. So how you will define a dual statement? Let S be a statement and S does not contains any other logical connectives other than these two. you can replace each occurrence of cap by cup, that is and by or by and also replace a contradiction by tautology, tautology by contradiction. This is the definition for dual. Okay. So what is principle of duality? For principle of duality, you should have two statements. Okay. So if S and T are two statements, so same condition, S and T does contains logical connectors only cap and cup. Okay, it should not contain any other logical connectors. Okay, so if you are having cap and cup, what is dual? In this case, cap will become cup and cup will become cap, that is and will become or will become and, right, for dual. So what is principle of duality? So you have to have two different statements. Whenever S is logically equivalent to T, if you are having this statement, then its dual is also logically equivalent. S dual is logically equivalent to T dual. This is nothing but principle of duality. So let S and T be the two statements. If S is logically equivalent to T, then S dual is also logically equivalent to T dual. Okay. So here they have given one compound statement. We have to negate the statement and we have to simplify the statement. So first we have to negate the statement. See here, we are having implication statement here. So firstly we have seen in the first logically equivalent example. Here you can observe what is negation PRQ. It is logically equivalent to P implies Q. We have proved, right? If you are having implication statement like this, you can negate the first statement, and if you operate with R and the second statement, it is same as this statement. So if you are having implication statement, you can write like this, negation PRQ. Okay, both are logically equivalent statement, right? So how you can replace this? What is the result we have seen there? It is P implies Q is logically equivalent to negation PRQ. Okay, so instead of P, we are having here P or Q. Implies R. So what you will replace? It is negation P or Q. Instead of P, we are having the whole term. So how you will write? It is PRQ implies R. It is logically equivalent to negation of first statement, that is PRQ R, the second statement R. Okay, so these two are logically equivalent. How? By the result already we have. So by what we have, how we can write? It is, if you are having S implies T, then it is logically equivalent to, what is the first statement? It is negation S is, it is negation is or T is logically equivalent to the implication statement. So same by the result we got this. Okay, so it is negation PRQ or. So now we have to negate the statement and we have to simplify the statement. Okay, so how you will negate the statement? Here negation of negation PRQ RR we are having, right? So we have to find the negation of this statement. So it is logically same as, if you take inside negation, it is nothing but De Morgan law. If you take inside negation, it will become negation of here PRQ. Okay, and R will become and here. Okay, and negation or you will get. How we got this? It is by De Morgan law. You have to mention De Morgan law. Okay, so next step, here we are having double negation, right? If you are having double negation, it is same as the value. Here we are having PRQ as the statement, so you will get the same statement PRQ by law of double negation and negation R. This is by law of double negation. You have to mention which law we have used to simplify this. Okay, so here you observe here we cannot simplify this further with any of the laws, right? So this is the simplified statement. So first we have negate the statement and then we have simplified the statement. Okay, so next one is implication. What is implication statement? If you are having two statements, P and Q, what is the implication statement? It is nothing but P implies Q, right? What is contrapositive of this implication statement? So if you are having implication statement, how you will write the contrapositive? It is nothing but negation Q implies negation P. It is contrapositive statement. Okay, you have to negate the second statement, which will imply the negation of the first statement. What is converse? Converse is nothing but Q implies P. What is inverse? Inverse is negation P implies negation Q. So implication, you know, contrapositive, negation Q implies negation P, converse is Q implies P, and inverse is negation P implies negation Q. So next we have to simplify the statement using the laws. Okay, so how we can simplify the statement? By using the laws. So what is the problem given here? It is negation of negation PRQ. Negation of negation PRQ, right? PRQ and R or negation Q we are having, right? So if you take inside the negation, what it will become? It is logically equivalent to. So negation of PRQ and R. Okay, close the bracket. This negation we have taken inside, negation of the whole value. So R will become and here, right? So it is and negation of negation Q. Here we are having negation Q. If you take inside negation, it will become negation Q. So by which law we got this? It is by De Morgan law. You have to mention the full. Okay, so it is De Morgan law. So if you apply double negation, it is the same statement you will get. It is logically equivalent to PRQ and R, right? And what else we are having? It is and negation of negation Q is also same as Q. By which law we got this? It is law of double negation. By law of double negation we got this result. Okay, so here you observe we are having PRQ and R and Q. So you can change the bracket, you can use the associativity. So PRQ and R and Q. So here we are having the same thing. Three elements we are having. This is considered as a single element. This is second element. This is third one. So you can change the bracket here. Okay. So R and Q. So by associative law. We got this. So R and Q is same as Q and R. Which law it is? It is nothing but commutative law. So by commutative law, we will get R and Q is same as Q and R, right? So next and we are having and P and Q will be as it is. So observe these two. Here we are having P and Q and we are having Q and R. So you can combine these two Qs. So if you are having three statements, okay, that is one statement is occurring two times with different connectors. Here we are having and here we are having or. So again you can use the associativity to change the bracket. So here you can change the bracket. So it is logically equivalent to PRQ and Q. Okay. Consider these as a single statement. This is a second statement, third statement. So we have changed the bracket by using associativity. Again by associativity law we got this. Okay. So what is PRQ and Q? it is the connectives are different here, and one statement is occurring 2 times, right? So if a single statement appears 2 times and the connectives are different, this is nothing but absorption law. So you will get the same statement Q. Whichever it is occurring to, you will get the same statement as Q. So here you will get the whole value as Q. So it is Q and what we are having R. How we got this? It is by absorption law. Okay. So you have to use the laws. See, wherever it is necessary, you have to identify and you have to use the laws to simplify the compound statement. Okay. So next one is, if we are having a network, that is a switching network. So here we are having, these are all P, Q or all switches. Okay. So switch may be either open or closed. So a current must pass through the terminal 1 to terminal 2. Okay. So whenever it is open, the current cannot pass. Okay. So if it is open, then the value is 0. Only if it is closed, if it is open, the current cannot pass through the network, right? So in that case, if it is open, the value is 0. If it is closed, you will get the value as 1. Okay. So here, what is P, Q, R? They are in the parallel, right? See here, it is parallel network. See, Q, T, negation T, this is a series network. So whenever you are having a statements in series form, you have to use, it is AND. For series, you have to use AND. And for parallel, you have to use R. So how you will write the answer for this question? See here, we are having P, Q, R. It is in parallel. So P, R, Q, R, R. You will use. And this whole thing is series. Okay. These are all in series. So and you have to use and between these series. Okay. So and. So PR, TR, negation Q. And PR, negation T, R, R. Okay. If you are having parallel network, you have to use the connective R. If you are having series network, then you have to use the connective as AND. Okay. So how you will write the statement, that is compound statement for this one? It is PR, QR, R. Okay. This is in parallel, right? P, see here, we are having PR, QR, R. And it will become series. Okay. And PR, TR, negation Q. It is and P, R, T, R, negation Q. And also we are having a series. So what is the connective you will use? It is AND. Okay. And PR, negation TR, R. So PR, negation TR, R. So this is the compound statement. You can identify it from that network diagram. If you simplify this network diagram, you will get one compound statement. See, here we are having one compound statement, right? So if you simplify that compound statement using the laws, okay, you will get one simplified statement, right? So for that we have the diagram. See what you will get. You can try. See, if you simplify that compound statement, you will get this answer. Okay. See here we are having P and this whole thing in parallel. This is also in parallel. Okay. So what is the connective you will use? It is PR. Okay. PR. What is this? It is, these two are in series. So R and. Okay. What we are having inside, it is T, negation Q. This is in parallel. So T, R, negation Q. If you are having parallel network, it is connective is R. If you are having series network, it is AND. So these two are in parallel. So P, the whole thing will become R here. Okay. P, R. Okay. So here these two are in series. So R and these two are in parallel. So it will become R. So this is how you have to write the statement from the network diagram. So if you simplified this compound statement, you will get the answer as this one, PR, R and TR negation Q. So we have seen today, so what is logical equivalent, what are the 10 laws of logic, okay, and what is dual, principle of duality, how to negate and simplify a compound statement by using the laws of logic, okay. So we have to know how to simplify the compound statement. The questions may arrive from simplify the compound statement, okay, they will give a compound statement, you have to simplify the compound statement using the laws of logic, and they may give one network